Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about the titrations. You know my friend, this topic is very important for chemistry student from 10 plus 2 to MSc. So we should learn titration method properly. So in this video, I will talk on introduction, principle of titration, terms used in titration, concentration term, titrimetric calculations, titrimetric apparatus, types of titration, fields of use, and advantages of titrations. So my friend, the outcome of this video will come like that you are able to do titration in the laboratory. So let us start learning of some important things related to titration. You know, a technique for determining the concentration of a solution by measuring the volume of one solution needed to completely react with the another solution. Titration process involves addition of solution of known concentration. Here known concentration is very important. From burette, and where you will find where is the known concentration in your burette to the measured volume of analyte. You know my friend, the principle of titration, it is based on the complete chemical reactions between the analyte and the reagent titrant of known concentration. So analyte plus titrant, it gives product. You know the term used in titration, and this term it is very clear to you, just like crystal clear, so that you will not face problem during your titration. So it is visible to in your brain or to your eye. What is analyte? The solution of unknown concentration but known volumes. What is titrant? The solution of known concentration. Now standard solution. You know my friends, what is the meaning of a standard solution? A solution of known concentration. A solution of known concentration. Here important term known concentration is called the standard solution. Types of standard solution. Primary standard, it has certain properties like extremely pure, highly stable, can be weighed easily. For example, sodium carbonate and KHP. Now secondary standard, it has certain properties, less pure than primary standard, less stable than primary standard, cannot be weighed easily, like sodium hydroxide and hydrochloric acid. My friend, another important term you should keep in your mind during your titrations, like equivalent point and end point. What is this? Equivalence point, point where the amount of two reactants are just equivalent. What is end point? Point at which the reaction is observed to be complete, and this point is usually observed with the help of indicator. So indicator we have to define. What is indicator? An auxiliary substance which helps in the usual detection of the completion of the titration process at the endpoint. For example, methyl orange, phenolphthalein, cresol red, and thymol blue. Now, concentration term. You know, my friend, you have to define the concentration. The concentration of standard solutions, which is also known as titrants, are generally expressed in units of either molarity or normality. Molarity cm or m, normality cn or n. You know the molarity from your previous classes. What is the molarity? It is the number of moles of a solute per liter of solution. Now we have to define the normality. It is the gram equivalent weight of solute dissolved per liter of solution. What is molality? It is the number of moles of solute present in per kilogram of solvent. So my friends, titrimetric or tritrimetric calculations, how you will perform calculation after performing your experiments. It is based on the following law of equivalence: NAVA, NSVS, MAVA, MSVS. What is the term MA, NA, VA? So NA is the normality of analyte, VA is the volume of the analyte, NA is the normality of a standard solution, VS is the volume of a standard solution used, MA is the molality of analyte, MS is the molality of a standard solution. Now, look at the apparatus which we are using during the titration. The apparatus, you can see 20 ml of acid solution in pipette. Now you can see the burette initial volume reading from the top and a standard sodium hydroxide solution in burette and 20 ml of acid solution in beaker. You can see this is the Elmenier flask. The special name is Elmenier flask. Now you can see the final volume at the time change in color. So neutralized solution indicator has changed color. So this is the apparatus setup for titration. Now types of titrations. You know, my friend, acid-base titrations, complexometry titrations, redox titration, and precipitation titrations. I will start now acid-base titration, which is also known as neutralizations. You all know this. So a sample of unknown concentration of acid is estimated with a known concentrated base or vice versa. Acid react with base, it give water and salt. Look at here the scheme. Now titrametric curve and types of acid-base titration. What is a titration curve? A titration curve is a graph of pH as a function of amount of titrant, acid or base added. So look at here, this is the titration curve for a strong acid versus strong base. You can see here the equivalence point. Now titration curve for a strong acid, weak base, you can see the equivalence point. Now titration curve for weak acid versus strong base, you can see the equivalence point. Now titration curve for weak acid and weak base, you can see the graph pattern. Now my friend, complexometric titrations. As the name indicates, the end point is seen by formation of a complex molecule. Here titrants and titrant react to form a complex till end point is reached. Once complex is formed, the complex is stable and not further reaction takes place. You can see the calcium EDTA reactions forming calcium EDTA, magnesium indicator EDTA, magnesium EDTA, and indicator. So redox titration A redox titration is based on the redox reaction, oxidation reduction between analyte and titrants. You can see here Fe2 plus converted into Fe3 plus. What will happen? Oxidation occurs. Here chromium converted to chromium 3 plus, reduction occurs. So this is the redox reactions. Now precipitation titration. This is also very important. The titration which are based on the formation of insoluble precipitates when the solution of two reacting substances are brought in contact with each other. This is very important sentence to understand this topic. Solution of two reacting substances are brought in contact with each other are called precipitation titration. You can look at here silver and Cl, it gives AgCl, which is solid and ionic form present in aqueous. Now my friends, method of precipitation titration. There are different types of method like Morse method, Vollard methods and Fazan's method. It involves formations of colored precipitate at the end point in case of Morse method. It involves formations of soluble colored complex at the end point at Vollard methods. It involves adsorption of a color indicator on the precipitate at the end point in Fazan's methods. So fields of use, where we are using the titrations. Titration is a widely applied analytical technique. Some areas where titration is used are in agriculture, oil industries, chemical industries, pharmaceuticals and food industries. What is the advantages of titration? There are several reasons why titration is used in laboratory worldwide. Titration is an established analytical technique. It is fast. It is a very accurate and precise technique. Titration offers a good precise price performance ratio as compared to more sophisticated technique. It can be used by low skilled and low trained operator. No need for highly specialized chemical knowledge. So my friends, I hope this video will be very helpful to you. If you like such type of video, then subscribe my channel and thanks for watching. I hope the idea, the motto of this video, you have to learn some important term and how you will perform titrations in the laboratory. It is much clear to you. Thank you very much.